We're on problem 7. Look at us. We're cranking along here. Write the equation for this line. All right, whenever I see a line that I can easily tell what the slope is and the y-intercept, I'm going to put it into slope-intercept form. Y equals mx plus b. This is my slope. That's where the slope's going to go, right there for m, right? And this is my y-intercept. Y-intercept. Y-intercept means like, where does it hit the y-axis? Well, it's hitting the y-axis at 8 because I think, like there's 8, there's 16, right? If we go up by 8, go up by 8, go up by 8. So I'm pretty sure it's hard to tell, but that's an 8 right there, right? It's not actually that hard. We're counting by 4s, I think. 4, 8, 12, 16, right? So here we go. Y equals, I'm going to put a plus 8 on the end of my equation. That's my y-intercept. Now, maybe the tricky part is to figure out what the slope is. Guys, when the function is decreasing, it has a negative slope when it's decreasing. This is a negative slope. So I'm going to start right out with a negative right there. And then how much is it going down by? It's going down one little tick, which is 4 in the scale, right? Taking the scale into consideration. And it's going over 2 ticks, which is 8. Now you could say it's just gone down 1 and over 2 because the scale is the same on the x and the y axis, but you can easily see like 4/8, right? My slope, let me put that out here. M is 4/8. That reduces down to 1/2. So I'm going to put, negative 1/2 x, and here's the equation of my line. Rise over run. There's my y-intercept. All right. All right, number 8, it says 8 through 10. We're going to make a sketch of the following graph. We want to clearly show that we can identify the transformation that's going on. So a -1 is going to give us a delay of 1. So this -1 is going to shift things right 1. And this +3 is going to take us up 3. So I want to go over 1. And I want to go up 1, 2, 3. And then I want to clearly show people that I know what the absolute value function looks like. The absolute value function has a slope of 1 when you're going to the right of the little turning point down here. It's not a vertex. I often want to call it a vertex. Kind of looks like 1 in a parabola, but parabolas are not hard turns like this. They're nice and smooth, continuous and differentiable. That's what the fancy word is. And so here we go. That's what my absolute value function looks like. I've shown my transformation and all that kind of stuff. We want to be able to do that. We can't use Desmos on the test. So we want to know that's what's happening there. Number 9, we've got to shift to the left. Things are going to happen 1 sooner than they normally would. So it's like that's left 1. Okay, left 1 and up 2. So we want to show that we know that information. So we go left 1 and we go up 2, 1, 2, and then we want to put a parabola down. So my parabola, it doesn't have any kind of vertical stretch on it. So a parabola goes over 1, up by 1. Then it goes over by 2 and it goes up by 4. 1, 2, 3, 4. So if I put a few points down to make this a little bit more accurate, all right, and then we go over 1, up 1, we go over 2, up 4, 1, 2, 3, 4. It has symmetry, right? A line of symmetry goes right through the middle of this thing. It's not the y-axis, but if there's still a line of symmetry going through the middle, it has line symmetry, right? All right, whew, here comes the last one. And it is a line, which is a good thing. So we go 1, 2, 3, 4 down. That's my y-intercept, right? Down 4. There, we've kind of reviewed this already. That's the y-intercept. And then 2/3 is the slope. Okay, so m is 2/3. So that means you got to go up by 2. 1, 2. The rise is 2, and the run is 3. 1, 2, 3, and put another point down. Now we just want a straight line going through that. We could do another one here. 1, 2, 1, 2, 3, right? So you have a couple points to hit there. And then put a little arrow on the end, put a little arrow on the end, and you're done. Now, I got to warn you, there is going to be an inequality problem on here. And that's what our little assignment is right after you're done going over the test. I could change this into an inequality problem. I could put down something like y is greater than 2/3 x minus 4. You're going to get some points for graphing the line. But if it's a greater than symbol, I've got to adjust my line a little bit. I got to make it so that there's dashes. My line is not a solid line anymore. It's a dash line if we are just greater than, not greater than or equal to, right? So make it clear that that that's what's going on. If there was a little bar underneath, then you make it a solid line. Okay. All right. Anyways, now I test out the origin. I love testing out the origin because, boy, I mean, there's no easier arithmetic than zeros. So I'm testing that, and I'm going to see if it gives me a true or false conclusion. So if I put 0 in for y and I put 0 in for x, what happens here? Is 0 greater than -4? Yes, it is, because here's 0 on a number line and here's -4 on a number line. Bigger numbers are to the right of smaller numbers. So this is a true statement. 0 is bigger than -4. So what we do next is we shade. I'm going to try to get my highlighter on to shade. And so we would shade like all of this stuff over here, saying, you know what? All these points that are up here give me true statements. You might say, well, you didn't test them all. I know I tested just one of them, but look, they're all in the same. They're all on the same side. Like this point here, the origin is on a particular side of this boundary, if you will. So that's our boundary. If we get one that's true, they're all true over here. Or if we get one, that's false over here, then they're all false, and we'd shade the other way. All right. So that's how you change this equation here into an inequality problem. This is now like problem number 11. All right. And we reviewed that yesterday, and that's the little activity that you have in class today. So, hey, thanks for watching my video. I appreciate you guys. Just do the best you can, and I'll help you if you need some help.